About network layer, the main function is the first one, addressing. This layer will also have address. We call it IP address. And the second one, about this part, we will use a layer 3 device like router, like layer 3 switch to forward the traffic according to the IP address. This process we call it routing. And the next part, about this layer, we also can provide some congestion control. For example, if the network resources is not enough, we hope we can forward the traffic. The important message can be forwarded as soon as possible. And we also can use this part to control this message. In this process, we call it QoS, quality of service. So the first one, let's see. The first function of the network layer is addressing. And about this layer, we will have address. And the address we call is IP address. The network layer address, we have two parts. The first one is network address, and another one is a host address. Two parts. And it has 32 bits long. And I think everyone sees this IP address, right? And this address in the global is unique. That means different devices will have different IP address. And the typical format is like this one, 10.8.2.48. And the first part belongs to the network address, and the second part belongs to the host address. Often we will use the IP address as the network layer address. And the next function of network layer is routing, right? And of this part, we have two protocols. The first protocol we call is routed protocol. And it defines the format and purpose of this layer. For example, what message should be added when we do the encapsulation of network layer? We say we have to add the IP address, right? Actually, we have two addresses. One is source IP address and another one is destination IP address. Why we need this message? That's because the routed protocol defines the format. And another protocol we call is routing protocol. And we say about the layer 3 device, like the router, forwarding the traffic according to the IP address information. But before we forward the packet, we also have to get the forwarding table. This one we call is IP routing table. So how to get to the routing table? This is a function of routing protocol. We will calculate the routes and form routing table. Then we have to select the best one and then to forward the table. So this is a function. And the typical topology like this one, we have different hosts and between them we have multiple routers, right? First, according to the routing protocol like ISIS, OSPF, and BGP, we can get the routing table. And then we will forward the traffic according to the IP address and searching the routing table. Of course, we have to encapsulate the packets, add the IP information, add the source IP, destination IP, some message like this. This depends on the routed protocol, and the typical routed protocol is IP. So we will see some IP header information. Then all the devices can forward the message according to the IP header, and then we can select the best path from the routing table. So this is the relationship between routed protocol and the routing protocol. And the next one, let's say the operation of network layer protocol. For example, now some message have to be transferred from host A to host B, and between them there are some routers. And about the host A, before we send the packets out, we have to do the encapsulation of this host A. For example, now I want to send the message to you. In the dinner, I hope we can have some talking and have some food with you, and what's the time, what's the place. This message now I want to use my phone and send the email to host B. And then the host A will choose the application is Outlook. And the computer will do the encapsulation from application to the physical layer. And about the network layer, we will add the source IP address of host A and destination IP address of host B. Then the message will become the bit finally sent to the gateway of router A. Gateway means if host A wants to send the message to different segment, the gateway will help you. So the packet will send to the router A. And the router A will do the de-encapsulation and delete the header of physical layer, the header of the data link layer, and according to the network layer information, I will say your destination IP address is host B. Then I will take the host B IP address and search the routing table, right? And the routing table will show us if you want to send the message to host B, you have to give this packet to the router B, not about router D, because we have two outer interface, right? And finally, the router A will choose to send the message to router B. This is the second process. Before I send the message out, I also have to encapsulate the packets to become a full message and then to the destination, to router B, to the next hop actually. And the router B will receive this message and do the same process like router A. Will delete the header information until the network layer and find the destination IP address is host B. Then I will encapsulate again, then to the next hop is router C. Finally, about router C will send the message to host B. And about the host B, as a receiver, I only focus on the data. I only want to know what's the time, what's the place we will have the dinner. So the computer will delete all the network information, deletes the physical layer, deletes the data link layer, deletes the application layer, finally give the sentence to the customer. So this is a whole process. And the next layer is a transport layer. This layer also is very important. And about this layer, we can provide the function, segment, app layer, date. Because about the transport layer, I will receive the message from the app layer of the session layer. I will add the information and make to become the segment. So I think, do you still remember what's the name of the transport layer, right? The name is segment. And then we have to establish an end-to-end connection and transmit the packets and provide the reliable transmission. And we also can provide the flow control. This is a function. And the typical protocol is TCP and UDP. Pay attention, please. We say about the transport layer, we can provide a reliable transmission. Depends on which protocol you use. If you use a TCP, you can use a reliable function, but UDP cannot. That means transport layer, if we use different protocol, we can provide different service. Let's say the first service we call is connection or return service. About this part, before we send the message to the destination, we have to establish the connection. After we finish the communication, we will delete the connection. And we also can provide ordered delivery. And after we send the message to the receiver have to give us the acknowledgement. If the message is okay, we will continue to send the next message. If we have some message lost or some message is wrong, we have to ask the sender to retransmit the message. And about this service, suitable for applications with high reliability requirements. For example, maybe you want to get some message on the bank. The password is very important, right? And about this scenario, this service, we hope we can use a connection-oriented service. But about another one, only provides the connectionless service. That means this is a best effort service, and there is no connection required. No sequence number mechanism, no confirm mechanism, no any mechanism. So this is suitable for applications with latency sensitive requirement. That means if you hope the transmission can be finished as soon as possible, you can choose this service. But suggestion, if your network is reliable enough, you can use this service. And the next layer is the session layer, presentation layer, and application layers. About RCNA cores, we only focus on the transport layer, network layer, and data link layer. So about these three layers, you only know the function is enough. For example, about the application layer, we provide the network service for application process, like the word processing. You also can use some email. Maybe you also can use HTTP to open some URL. And the second one defines the data format and the structure, like some JPEG, like some ASC. And about the session layer, focus on the session information, establish, maintain, and finally release the session information. And about the last, there is a question of this video. Which of the following statements about the OSI reference mode is true? That means you have to select a correct statement. Option A, B, and C. The data of transport layer is called frame. The data of network layer is called segment. The data of data link layer is called packet. And the data of physical layer is called bit. So all the options will only have one correct answer. That's all. Thank you.
Hello guys, now I think you are ready to see the training video for the OSI reference mode. Now let me have a brief summary for you. About the OSI reference mode, first you have to know the different layers, the name, the function, and after we finish the encapsulation, what's the protocol name, right? For example, after we add the information of the network layer, the packet we say is a packet. And about the data link layer, this we will call is a frame. So this is a basic function. And the next one is the advantage of the hierarchical structure. About OSI reference mode, we will divide the network of 7 layers from the bottom up. And the first layer is a physical layer, and the second one is a data link layer, and the seventh layer is application layer. So after we finish the hierarchical structure, it's useful to help us understand the network, learning the network, and also it's very useful to do the troubleshooting. So this is a part of the OSI reference mode. Of course, don't forget to finish the practice I assigned for you. Thank you.